This is the last section of Chapter 6. We turn to binomial distributions. So there are only two possible outcomes for binomial. That's what the bi means, as in bicycle, binoculars. So examples are a credit card offer. So you say yes or no. So these are things like married, not married, things that only have two possible outcomes. So you will have n trials. So this is known in advance how many you will have. And each one will be called a success or a failure. Each trial has the same probability of success. We're going to call that little p. So the probability of failure is the opposite. It's complement, 1 minus p. So if the probability of success is 0.1, the probability of not having it happen is 0.9, because everything must add up to 1. The n trials are independent. That means what you got for one trial has no influence on the other trials. Now, sometimes people mistake a situation like this as binomial, and it's not. You keep calling, making calls until you get a sale. So each time the person might say yes or no, and you make calls until you get a sale. But you don't know in advance how many calls you might have to make. You may have to make 1, you may have to make 100. So that is not a binomial distribution. Binomial distribution, you might say, I'm going to make 100 calls and see how many sales I get. And again, when we talk about the random variable itself, we use a capital, and we're talking about the number of successes. Here's the formula for it, and it's a little new to a lot of people. So I put in an example how to fill in the formula for you, and it's read this way. The probability of x is equal to n factorial over x factorial quantity n minus x factorial times the probability raised to the x power times 1 minus the probability, that quantity raised to the n minus x power. And you see to the right the possible values given for x. 0, 1, 2, 3 up to n. So you can have no successes, you can have 1, you can have 2. And if you have n trials, like 100 trials, you could have 100 successes. So here's an example how to fill in a formula. First thing I do is I write the formula. And the second thing I do is I replace the n by 9, the x by 3, the n minus x, that's 9 minus 3 by 6. And I now take my calculator and work it out. And I'll show you several ways of doing that. Factorials mean this. 3 factorial means 1 times 2 times 3. And a couple of rules you have to learn are 1 factorial is 1 and 0 factorial is 1. And an example is given at the bottom. So suppose you have a group of women and they claim that they're less likely to be promoted than the male employees. And we have exactly 500 employees that are female, 500 employees that are male. And 10 were chosen from management, but none of them were female. What's the probability that this would actually happen randomly? So you plug it in, check out the answer, and it says 1 in 1,000. So that seems pretty unlikely. This is what they use when they're going to court as an example of how stats help win court battles or lose them sometimes. So binary data, that just means success or failure. Same probability for success on each trial. So you have the same chance of having success on the 15th trial as you do on the 7th. The trials are independent of each other. So when we looked at the data, did we only have 2, male and female? Yes. If they're selected randomly, the probability of a female on a given trial is 0.5. It's the same for every trial. So that's correct. That's the criterion. And if you have a large population, the randomness of taking 10 from a large population ensures that one trial doesn't depend on the outcome of another trial. Now large here is because they're not actually putting the employees back into the pot. So this is like cards, this is without replacement. But you can get away with it if you have a large enough population you're choosing from. It doesn't affect the probability very much. So it's an approximation. The binomial mean and standard deviation is pretty easy to find. And remember, this is for the population, so you actually have parameters. Mu, the mean, is equal to n times the probability. So n is the number of trials, p is the probability. Sigma, the standard deviation, is equal to the square root of np times 1 minus p. And you need to memorize this one. So in New York, they've got about 500,000 people who are pedestrians who were suspected for criminal violations. So these are people not in the cars. That's all they're saying. It says basically about 89% were not white, of the people that they suspected of criminal violations. And it said, looking at the census, that of the 8 million people living in there, 44.6% were white. So this seems to be like a possible case of racial profiling. So how do we go about checking this? Well, let's assume those 500,000 confrontations are the same as trials. And you have a probability of someone being non-white is 0.554. So that means the probability of them being white is 1 minus 0.554. We can calculate the mean and the standard deviation using a formula. The mean is approximately 277,000, so about 250,000. Standard deviation is about 351. Now, just using the empirical formula, you could go out 3 standard deviations either side and account for over 99%. If you went 3 standard deviations, you're approximately going to about 1,000 people. So you're looking at a range of about 276 to 278,000. And there it is, a little more precisely. But how many did they actually stop? Well, it said 88.9% of the 500,000 involved non-whites, but you would expect it to actually be in the range of 276 to 278,000 over 99% of the time. So this is pretty suspect. And that's the end of our chapter.